We have our model set up with a single random variable, in this case a demand. And if we cycle the model, we can see that the profit changes somewhat, but we don't know what the overall outcome is going to be. If you think about it, running the model once is kind of like throwing a die. It may not be indicative of what the natural probability would be. You throw a die and you get a 1. Does that mean that's going to be the average value? No, you need to throw the die many times. And that's the point of the Monte Carlo simulation. We want to run this simulation many times and not do it manually. So here's how we're going to do that. If you remember, we did a what if using the data table, and in it we were able to cycle two variables and compare them over a limited number of iterations. But there's a way we can trick Excel into running more than just a few iterations by using the data table. And here's how we're going to do it. First thing we need to do, and I've set up the beginnings of my table here, we want to run this time 1,000 trials. And we need to have the column show 1,000. So the easiest way to do that, besides dragging it down, you could drag it if it was only 100. 1,000 is not too bad. But if you go to the Home tab and Fill, Series, click Column, because we want the column, and we want to start at 1, go to 1,000. And just click OK, and Excel will fill in 1,000 points there. So that gives us one leg of our data table. The other thing we need to do is to put in the table our random variable. Here I'm going to link to demand, which remember is our random variable. So we have that value in the table. The other thing we want to see though is what the profit is. What is the outcome? So I'm going to link to that as well. Now we've got the beginnings of the table, and this is the important part. We need to select the whole table. Remember how we did that? And here we're going to use Control-Shift-Down arrow to select that range. It includes the whole thing. And I'm going to just drag it back up there. And now all we need to do is go to Data, What If Analysis, Data Table. Ignore the row input. We're not interested in the rows here. We're interested in the columns. So we need to put in a column cell, but we don't want to have any values there. We always want the column cell to be blank. I made one up here. I'm calling it column cell and colored it goldish orange to remind myself not to put anything in that cell ever. And then I just click OK. And Excel will run that simulation, this time 1,000 trials, and give us the demand that comes out of each one of those random trials and the profit that it generates. So we've got a lot of good information there. I've already gone ahead. I'm going to unhide some columns I have here, and I've put in formulas to calculate the mean of that range of profit, the standard deviation of that range of profit, those 1,000 iterations, the min and the max, and then using the norm dis to calculate the probability of X being less than $250, or profit being less than $250. You can see that based on this simulation, there's about a 71% chance our newsboy will make less than $250 if he purchases 4,200 copies. And the reason that I put 4,200 in here was logically, you look down and say, well, the mean of my distribution, the average is 4,200, so I'm going to buy the average. But in this case, we've got some variation, and that's what the simulation is showing us, that in this case, the mean of the profit would be about $238. The minimum could be as low as $116 and as much as $252 with about a 71% chance. Okay, now that is a single random variable. You need to be aware that if your model has more than one random variable, depending upon how you set it up, you may need to include more than just the single random variable in the data table. In this variation of the newsboy model, I have also changed the purchase quantity into a random variable. And the way I did that was similar to what we did with the demand. I'm just going to assume that, again, it is normally distributed with a mean of 4,200 and a standard deviation 400. But I set up a separate random variable down here. You notice I've got a cell with the rand function in it, and then also the norm inverse function. And you might notice right away that the two rand values are different. And that is important, that because I'm using two separate Excel rand functions, they will be different every time you exercise the model. You can see when I calculate the sheet, the two rand functions return different values, and because the demand and the Q are each linked to those separate rand functions, the two values are different. And here's why that's important. In this first area, I set the table up the way I did in the first part of the video, just with the single random variable showing, and found the profit and the mean and standard deviation. In the second version, I included the second random variable, the Q, and also found the mean and standard deviation of those 1,000 simulations. And you can see the means are slightly different, standard deviations are different, and everything is slightly different because you're including both of those random variables. In this particular case, it doesn't give you a significantly different answer, 78% versus 77%, but it might, depending upon your model. And the difference is, some people, when they build models with multiple random variables, would link their random variables to the same rand function. You could do that. And if you're using a single rand function, then you just need to have a single random variable in your table. If you're using multiple rand functions, then you need to have each variable that has a separate rand function in your data table. That begs the question, why should you use more than one rand function if it just makes you have to do more work? Well, if you think about it, these may be separate processes total. Demand is totally different from the purchase quantity. So it wouldn't make sense in my mind to have the same random function, the same dice being thrown to determine the purchase quantity and the demand. My mind would be that it's better to have separate rand functions built into these variables as opposed to link them all to one rand function, unless they all start at the same genesis. And in most problems, your variables do not have a common base. Therefore, you should use separate rand functions.